Welcome back to Data Hikes. We have looked at ER diagrams and their various components like entities, relationships, attributes, etc. Now we will actually be looking at what goes into a database. The main idea of a database is a place where we can store data in the form of tables. So today we'll be looking at the introduction to tables. We'll first look at what structured data means, tables, columns, rows, etc. Then we'll look at the large level classification and then also the root level classification of various data types in a database. And the third thing we're going to cover is the various types of keys in a database system. Let's start with what structured data is. In a database context, structured data basically means data in a tabular format. Stored in a tabular format, if you're a mathematics student, you may call it simply a two-dimensional matrix. This is what a structured data looks like. Now, basically, of course, this is a table and it is made up of rows which are the horizontal entities over here and columns which are the vertical entities that you see here. Okay, and when I say entities here, I don't literally mean entities from the entity relationship models. I just mean, hey, these are the columns and these are the rows, whatever you see horizontally here. What are columns in a database context? Columns in a database in table describe the meaning of the data. So when you look at one column, you'll understand, hey, what kind of data is stored here? Columns are very often also referred to as attributes, variables, or fields. And in structured data, columns have the same type of data. We will look at the various types of data there are, but in a structured data, the columns would have the same type of data in them. The attributes from an ER diagram would likely be columns in a table, as we have mentioned before. For example, here, when we say a table, the column describes the meaning of the data. This tells us that the location ID is basically the unique identifier for a warehouse for this particular company. The market tells us the market as defined by the company that the warehouse services. The capacity is the capacity of the warehouse in square feet. So the columns tell us the meaning of the data that they will be holding. That is how columns work in a table. The next thing we're going to look at is rows. Rows are basically the set of values for all columns in a table. So they're also referred to as records or tuples. Basically, when you look at the data horizontally, they will be rows of the data. Rows are useful to identify an instance of the table. What does that really mean? It means, okay, this table holds a lot of information about various locations in this case. Now, what is an instance? Hey, there are three instances we can say, or three rows in this table. We can say, hey, tell me more about this instance of the table. When we look at one instance of a table, it means we're looking at one entire row and it tells us a story, right? This tells us warehouse number 34934 services the New York market and has a capacity of 125,000 square feet. So this is the complete story for this particular row, and that is how we identify a row, because all this information is related to each other. The next thing we'll be looking at is categorical data versus numerical data. This is basically the high-level classification of data. Categorical data classifies information for a column by names or labels. So if you look at a column and you mostly see some kinds of names or some kinds of classifiers in it, it is categorical data. We'll see exactly how we identify categorical versus numerical data as we move. So we'll get there when we do. It is also, so categorical data is also referred to as qualitative data. So it's not quantitative like numerical would be, but it's qualitative. It tells us, it describes the column or the values in the column more. The categorical data with no order is called nominal data. Now, categorical data can also have an order, like we can see, but in cases where categorical data has no order, it's nominal data. For example, department, gender. So the various values that a department column can hold, there's not really a hierarchy to it. It's not like, hey, this value is above or greater than the other. Same stands for the gender column as well. Now, categorical data that is ordered is called ordinal data. For example, grade, level, etc. So let's take the example of grade, and we can say that, okay, a grade goes from A, B, C, D, F, right? So these 5 grades do have an order to it, even though it is categorical data technically. It has an order. So A is a better grade than B, which is a fact, and categorical data that is ordered is hence called ordinal data. Next, we'll look at numerical data. It is basically any kind of number that can have mathematical operations performed on it. So this kind of data is referred to as quantitative data. Let's see exactly how we can understand whether data is categorical or numerical by asking simple questions about a column. The first question we want to ask is, are the values that the column holds numbers? If the answer to that is no, if the values are not numbers, then it is just straight up categorical data. There's no second thought about it. If the values are numbers, we ask the next question. We ask, is it meaningful to perform mathematical operations on these numbers? Now, if it is meaningful to perform mathematical operations on these numbers, if like adding, subtracting, multiplying these numbers make logical sense in the context of that table, then yes, it is numerical data. If the answer to this is no, it is still categorical data. We'll understand how that works when we actually look at some examples. Let's look at the table that we were seeing before, right? The first column is a location ID. Let's look at the first question we have. Are the values numbers? The answer to that is yes, these are definitely all numbers. Now we go down this path. Is it meaningful to perform mathematical operations on these numbers? Now these are just location IDs. I don't really see how performing mathematical operations on these makes any sense, because can you really tell me anything if I say, hey, give me the value of 53489 minus 34934? Give me, like, adding these numbers don't really have any meaning. Hence, it is not meaningful to perform mathematical operations on these numbers. Hence, this data is still categorical data. We go down the path for the no. The next column we are seeing is market. It has values like Houston, Los Angeles, New York. It's basically text data. Are these values numbers is the first question we are asking. The answer there is straight up no. Hence, this is categorical data. The third column we're looking at is the capacity. And the capacity is 100,000, 140,000, 125,000. Are these values numbers? Yes, of course, they are numbers. Go down this path. We say yes. Is it meaningful to perform mathematical operations on these numbers? Capacity. Sure. It would make sense if I say, hey, what is the capacity of Houston? It's 100,000 square feet. I want to send 75,000 square feet worth of inventory to that location. What would the capacity now be? It would be 100,000 minus 75,000, 25,000 for example. So performing mathematical operations on this column makes sense. Hence, this is numerical data. We'll be looking at the most common data types in database systems now. First, in the categorical data section, we have string or text, which is the most common type of categorical data. Like we saw market in the previous slide, it is just text information. It is very often represented in database systems using quotation marks around it. Single quotes, double quotes, it can be either, but string or text data is the most common type of categorical data. The next type we will come across is Boolean. What is Boolean? Categorical data that can have only one of two values, is binary. These columns are very often just true or false switches. So, there may be a column which says is capable of holding more goods. I mean, a column name should not be that big, but okay, the column name may simply be is at capacity question mark. That can be a column name, and the values can just be true or false for that. So if a building is full, it will be true because this building is at capacity now. And if it is false, the building still has some space in it. So it can have only two values, hence it is Boolean. The third one is date time. Date time can be categorical data. Now I'll say why I say can be here when we look at the numerical data side of things. But for now, you can understand that date can be categorical data because date has many components. Date time has day, month, year, hours, minutes, seconds. So we can, roll up to any of these numbers and any of these sections of a date and look at it as a category. For example, here I'm saying, even though maybe I had data at the daily level, but I'm saying, hey, for the entire month uh, of January, what are my sales? And then for the entire month of February, what are my sales? The other side we are seeing is numerical data. First data type we see here is integers, numbers that only make sense as integer values. For example, I can't really say I have 1.5 washing machine at this store. It has to be either 1 or 2 washing machines, right? So numbers that have quantities, some obvious quantities that can't really be partial or fractional numbers would be integers. Floats, on the other hand, basically numbers that can have fractional values, like sales. Sales can be for, hey, sales for a week at the store are $102,564.78, which makes sense. Sales can be in the fraction. Now, I have date time here again, and that can be confusing because date time can be treated as a category as we saw here, but mathematical operations can also be performed in some databases in the date time. We can say I have today's date, for example, 24/11, which is the 24th of November. I say I want the sales from 14 days ago. So I say whatever the date is 14 days ago, give me that date. So the database system gives me the date which is 14 days ago, which is the 10th of November. So that's the kind of mathematical operation you can do on date fields, even though they are technically categorical columns. Now we look at types of keys in a database or in a table. The first is the primary key, the column that holds values to uniquely identify rows in a table. This is the primary key. So there are two conditions that a primary key has to satisfy. The first one is it has to be unique. So all values in a primary key column, they have to be unique. No values can be duplicate values in the same column for a primary key column. And a primary key column cannot have null values. Now we'll look at examples of what null values look like when we get to databases, but null values basically just mean no value. So none of the values in a primary key column can just be blank. Looking at an example here from before, location ID, market, and capacity, we see that the location ID is the primary key here. There are no repeating numbers, repeating IDs over here. and this is the primary key for this table. The next key we'll be looking at is a foreign key. Now, a foreign key is a column that is tied to the primary key of another table. Whatever values exist in the foreign key column have to be present in the primary key column of the other table. This can sound a little confusing, but we can show you here how exactly that would work. We have had the first table, this is the second table. This is an employee table though. This is not a location table anymore. So for an employee table, the employee ID is the primary key. That makes sense. There are 3 values here, all 3 are unique, and that satisfies, and none of them are blank, so that satisfies the conditions for this being a primary key. The second column, however, is a location ID column. Location ID column has nothing to do with the primary key of this table. However, it is a foreign key and it is tied to the primary key of the location table. Now what does this mean? This means that whatever values will be in this column, they have to exist in the ID column or the primary key column of its parent table. So this connection tells us that whatever values will be here have to be here. So you see here that this value is repeated here, right? So location ID is definitely not a primary key in this table's context, because that doesn't make any sense, because 2 employees can work at the same location. That makes total sense. But this location has to exist in the location table. For example, if we try to put in something like, hey, PW586 works at location 12564. There is no 12564 in this table. Hence, this kind of a field or this kind of a row will not be allowed in here because the location ID doesn't exist up here. I hope that makes the concept of the foreign key very clear. The next key we'll be looking at is the composite key. A composite key is basically just a primary key that needs more than 1 columns to maintain uniqueness. We'll look at an example. Now, I want to look at the in stocks, right, for a particular product. I am using a combination of product ID and location ID as the primary key here. Now, product, just the dimensions of the products XYZ, that may be a separate table that exists somewhere. The location table is the table right here, say, for that gives us the location. And the quantity, but this table tells us about, hey, what product is stored at what location and how much quantity does it hold, right? So this combination is the entire primary key for this table, because you see these have values repeated here. So the product ID is not unique, but what is unique is the combination of these 2 columns. Hence, this is basically a composite key that is being used in this table. I hope that makes this very clear, and thank you for listening to today's lecture, and I hope the idea of what a table means, the various types of data that a table can hold, and the keys were clear. Give me whatever feedback you have in comments, and I have a syllabus prepared for the next lectures, but let me know what you guys would like to hear from me. Thank you.